So next topic which we are going to discuss is your Ethernet. Ethernet is your wired LAN technology, okay, which you have used in your home, in your college. Everyone has used your Ethernet. It is a wired LAN technology, and it operates in both data link layer and physical layer. And the standards which the Ethernet uses is IEEE 802.2 and 802.3 standards, and it came into existence by in 1983. Okay, so the bandwidth supported by your Ethernet is 10, 100, 1000, 10,000, 40,000 and 100 Gbps it, it supports. Okay, so your Ethernet standards is, it will define your layer 2 protocols and your layer 1 technologies. There are two separate sub layers in your data link layer. One is your logical link control layer, another one is your MAC sub layer. Okay, so Ethernet is used in both. This is the evolution of your Ethernet. First came 10 base 2 Ethernets. Okay, so 10 is the speed, then base is your baseband, and 2 is stands for 200 meter. If this is the case, the Ethernet was called as thin Ethernet. Similarly, for 10 base 5, it was called as thick Ethernet. Then you came twisted pair, fiber cable, fast Ethernet. Then you got 10 gigabits base T, which is called as gigabit Ethernet. Now Ethernet is used up to 400 Gbps speed. Okay, the topologies which are used for Ethernet is bus and star, but most commonly used topology is your bus topology. Next, this is the frame, Ethernet frame format. In Ethernet frame format, first we have preamble, and this next we have SFD, called as start frame delimiter. These two segments will be added by your physical layer. Okay, your preamble and start frame delimiter will be added by the physical layer, and from destination address to CRC it will be added in the data link layer. Your preamble and start frame delimiter are fixed. Okay, first came your start frame delimiter. So the value of start frame delimiter is this. Okay, 1010 10 and 11. It was fixed before to warn the receiver, to say the receiver that a frame is coming. Okay, to notify the receiver frame is coming. Start frame delimiter was initially used. Only that was there. Not preamble was not there. So by seeing the start frame delimiter data, the receiver will know that a data is coming. But now, since the data are more in number, the SFD flag combination can also come inside your data. Okay, so it will be a confusion. So for that, now preamble segment is also added from the physical layer, and preamble is also fixed. It is 56 bits of alternate ones and zeros. Okay, so first preamble start frame delimiter will be there in an Ethernet frame format, and it will be from your physical layer. Okay, so next we'll talk about the frame of your Ethernet from your data link layer. So first you have Ethernet header. Okay, Ethernet header will tell the details about your data which is to be followed. First you have the destination address. Next you have source address. Okay, so this destination address and source address will be your MAC address. Okay, next the length. Okay, the length of the data. Next your data, which is your pure payload. Okay, your pure data. Then for error correction you have your CRC at the last. At any frame at the last you have something for error correction and detection. Okay, so here if you see, the minimum frame length is 64 bytes. Okay, if you calculate from your destination address to your CRC, your minimum frame length is 64 bytes and your maximum frame length is 1518 bytes. Okay, so Ethernet address can be unicast or multicast. And how we'll find that is, the address, the first LSB address we'll see. Okay, you'll take the first byte of your address and you'll see the LSB of it. If the LSB is 0, it is a unicast address. If the LSB is 1, it is a multicast address. Okay, And if all your address is one, it means it is a broadcast address. Okay, so this is the common format of your MAC address. So MAC address is nothing but your physical address, your hardware address. It is also called as your Ethernet address.